Hello, this is Dr. Henry, and we're going to be talking about redox reactions. And in this first part, we're going to look at what are called oxidation numbers. And redox reactions really stands for reduction and oxidation. And these are reactions where there is a transfer of electrons between two species in the reaction. And we have to learn what are called oxidation numbers to keep track of these electrons. And they are sort of like these pseudo charges, these fake charges that we are assigning according to the following rules. And these oxidation numbers help us keep track of basically what's gaining electrons in a reaction and what is losing electrons in a reaction. So the first rule is the oxidation number of an element in its elementary state is 0. So fluorine, silver are 0. Any of the diatomic molecules, Brinkelhoff, are 0. For a monoatomic ion, it's the charge of that ion. So iron 2 is plus 2. Iron 3 is plus 3. Aluminum plus 3 is plus 3. For the group 1 elements, lithium, sodium, potassium, etc., their oxidation number is plus 2. For group 2, it's plus 2, and then for fluorine, it is negative 1. Rule number 4. So for hydrogen, the oxidation number is almost always plus 1. For oxygen, it's negative 2. And then rule number 5. Rule number 5 here is important. Basically, in a molecule, the oxidation numbers must add up to 0. In a polyatomic ion, the sum is the charge of the ion. So let me just show you some examples. This may be easier to follow here. And let me find my examples. All right, so here's an example. Let's look at MnO4 negative. Now, if we look at our rules, we know that oxygen is almost always negative 2. So we have 4 oxygen, so that's negative 8. We know the whole thing is equal to negative 1. We have 1 manganese, so what's going to give us negative 1 when we subtract 8 from it? And that's going to be 7. So in this example, manganese has an oxidation number of plus 7. All right, let's look at another example. Let's look at the charges in basically a molecule of sulfuric acid. So we know that hydrogen is plus 1, so this is plus 2. We know oxygen is negative 2. We have 4 times negative 2 is negative 8. And since it didn't have a charge, the whole molecule is equal to 0. So in order for this to add up to 0, sulfur has to be 6. So sulfur has a oxidation number of plus 6. And this is kind of strange because we know that sulfur, the element, forms ions with a charge of negative 2. And this is why this is a pseudo charge. All right, let's look at one more example. We look at Cr2O7, and this has a charge of negative 2. So the whole charge is equal to negative 2. So oxygen is negative 2, so there's 7 oxygens, so that's negative 14. We have 2 chromiums. So 2 times what? Minus 14 is going to give us negative 2. So we know that 12 minus 14 is negative 2. So 2 times 6 will end up with the negative 2. So this chromium has a charge of plus 6. And that's basically how you find oxidation numbers. And we're going to see why those are important in our next little video.